All right, so now what we're going to do is put that idea of finding a binomial probability in the most efficient manner to good use. So the first thing I want you to realize is that these are all binomial situations. In this first one, when John Isner is serving in tennis, one serve does not impact the next. Everyone is like a fresh start and a fresh slate. There is a success and a failure. He either wins the point or he doesn't win the point. And the probability that he makes that first serve is the same in every case, 78%. So the question is, what's the probability out of the next 5 first serves attempts he wins at least one of those first serve points? So that means one or more, or in other words, 1 to 5 of his first serves. So you can add up the probability of making 1 and 2 and 3 and 4 and 5 serves, or we can do 1 minus the probability of the only number of first serves not included in this question, which is he doesn't make any of them. He misses every single one of them in this case. So that will be far more efficient than adding up 5 separate individual probabilities. So if we take 1 minus the probability he misses them all, he has a total of 5 attempts. Choose 0 because he's going to make 0 or win the point 0 times in this scenario. Then we multiply by the probability he wins that point, and he's going to win 0 times, and then we're going to multiply by the probability he loses that point, which would be 22% of the time, and he would lose 5 times. So then we want 1 minus this calculation, and we will find that the probability that he makes at least one first serve or wins at least one first serve is 0.999. In other words, his chances are pretty darn good. All right, there are 100 sunny days a year in Ketchikan, Alaska, making the probability it's sunny on the day you visit about 0.27. You're in Ketchikan for 7 days. What's the probability it's sunny at most 5 of the 7 days you're there? So again, at most 5 is a maximum of 5. And so you could have anywhere from 0 sunny days up to 5 sunny days, or perhaps 6 or perhaps 7 sunny days, but altogether those probabilities total 1. Now at most 5 is a maximum of 5, and so we are looking at wanting to find the probability there are 0 to 5 sunny days. The most efficient way to do this is going to be to subtract the likelihood that there are 6 or 7 sunny days from both sides of the equation to give us that maximum of 5. Again, it's still quite a bit of work. We got to do 2 steps, but that's certainly better than 0 through 5, which is 6 different steps. So as we calculate, we'll take 1 minus the probability of 6 sunny days. So we're there 7 days. We would choose which 6 are sunny. The likelihood it's sunny is 0.27. We're going to look at 6 sunny days. The likelihood it is not sunny is 0.73, and it would be not sunny one of those 7 days. And then we're also going to subtract the likelihood that it's sunny the entire time we're there. So again, sun, so 0.27, and we'd be sunny all 7 days. The likelihood it's not sunny, we would have no sun, just one or none of those 7 days in this particular case. Please be sure you're subtracting both of those. Don't turn around and add again. We need to subtract those. We will find the likelihood it's sunny at most 5 days is 0.998. All right, as we've done several times in the past, would you please go ahead and pause the video and set up the next 2 problems using that idea of being as efficient as possible. So use those ideas of subtraction and then restart the video and see how you did. Okay, so compare what you came up with to what I've got. And again, I've tried to kind of help you find out where the totals and the number of successes and the probability of successes come from. The highlighted portion is what we're trying to calculate. Again, that would be the long version, many steps in some cases to get that done. So if that's what we want, by using subtraction from both sides of the equation, we can get to the more efficient method of calculating that probability. As always, if you have questions, go to the forum and post the questions that you have. And as always, be checking to see if you can help out a peer as well.